This video is about identifying x and y intercepts from an equation in a graph and putting an equation in standard form. So the math club at L to raise funds for the trip. The club members buy 20 cases of 24 candy bars for $200. So what does the y-intercept mean? So the y-intercept is where we are crossing the y-axis, which is at 0, negative 200. So 0 is representing the candy bars and negative 200 is representing the money. So with 0 bars sold, the profit is negative $200. And this happens because they bought the candy, but they need to earn their money back. So in number 2, it says, what coordinate does it cross at the x-axis? So the x-axis is our horizontal axis. We are crossing at 100, 0. And in this case, this means with 100 bars sold, the profit is $0, which means at this point they've made back their money for selling the candy bars, so anything above that is going to be a profit for them. So the y-intercept is where the line crosses the y-axis. Therefore, the y-intercept always has an x value of 0. The x-intercept is where the line crosses the x-axis. Therefore, the x-intercept always has a y value of 0. So looking at the graphs, let's find the x and y-intercepts. So number 4, the x-intercept, where we're crossing the x-axis at negative 6, so we would have negative 6, 0. The y-axis, or the y-intercept, where we're crossing the y-axis, so it's 0, negative 2. In number 5, our x-intercept would be negative 4, 0, and our y-intercept would be 0, 6. Now, in 6 and 7, we're only going to have one of each because of the type of line. So when we have a vertical line, it's going through the x-axis only, so it's only going to have an x-intercept. It's not going to have a y-intercept. Whereas it's when it's a horizontal line, it goes through the y-axis and not the x-axis. So the x-axis is not going to have an intercept. The y-intercept is going to be 0, negative 5. So now let's switch and we're going to graph them when they give us the intercept. So the x-intercept is going to go on the horizontal axis and the y-intercept is going to go on the vertical axis. So the x-intercept is at negative 9, 0. The y-intercept is at 0, 4. And then we can connect our points to make our line. Make sure we have arrows on the end of our lines. So in number 9, the x-intercept is 7. The y-intercept is 1, and then we would connect our points to form our line. Number 10, the x-intercept is negative 5, the y-intercept is negative 3, and we connect our points to form our line, adding our arrows. Now, what happens if we are given a graph like 15x minus 5y equals 30? So if I want to quickly graph this, instead of solving for y, what I can do is find my y-intercepts. When I find my y-intercept, I put 0 in for x, which leaves me with negative 5y is equal to 30, so y is negative 6. So my y-intercept would be 0, negative 6, because we put 0 in for x to get negative 6. To find the x-intercept, we're going to put 0 in for y. So 15x minus 5 times 0 equals 30. That's going to cancel out that 5, so we have 15x equals 30. When we divide, x is 2. So our x-intercept would be 2, 0. So I can plot that point, and I can connect those to graph my line. So for a recap, when we are trying to find our x-intercept, we're going to put 0 in for x, and we're going to solve for y. When we're trying to find the x-intercept, we put 0 in for y and we solve for x. So basically what's going to happen though is we're just going to ignore the variable that we're not trying to find because that's going to have a value of 0. So in number 11, we have 3x plus 5y equals 15. So to find the x-intercept, we're just going to say 3x equals 15. When we divide by 3, x equal to 5, so we have 5, 0. Then to find our y-intercept, we have 5y equals 15. We can divide both sides by 5. So y is 3, so we would have 0, 3. So whichever variable we ignored, we're going to put a 0 and then solve for our other variable. So in number 12, 12x minus 12y equals negative 24. So we have 12x equals negative 24. We can divide by 12. So x is negative 2. So we have negative 2, 0. And then in our second part, we have negative 12y equals negative 24. So we can divide by negative 12. And we get y equals 2. So we would have 0, 2. Once we have our x and y intercepts for both problems, we can graph. So going back to the first problem, our x-intercept was 5, 0. Our y-intercept was 0, 3. We connect our points. Same thing in the other graph. Our x-intercept is negative 2. Y-intercept is positive 2. And we can connect our points. So what is one benefit of graphing by intercepts? When we graph by intercepts, it is a quicker method because we just need to find the x and y by dividing. What is one benefit to graphing? So let's say, for example, we have 5x plus 4y equals 8. When I go to find the x-intercept here, we would get a fraction. Sometimes that is hard to graph, but if we were in slope-intercept, even if the x-intercept is a decimal, we can still graph our line easily. So sometimes it's not appropriate to use our x and y intercepts. It's better to use slope-intercept form of the y equals mx plus b. Which method is going to give us a more accurate graph? It's going to be slope-intercept because there are more points on the graph.